This is example 2B3 from the Dynamics textbook by Victoria Green and Mariah Rodriguez. Given we have a cable is wrapped around the inner radius of a spool. End A of the cable is moving to the right with a speed of VA. The spool is able to roll without slipping on a rough horizontal surface. We are asked to find the velocity of the center O of the spool and the angular velocity of the spool using the method of instant centers. We are given the values VA is equal to 0.8 meters per second, little r is equal to 0.3 meters, and big R is equal to 0.9 meters. Since there is no slip at the bottom of the spool, we know that the instant center is at point C. We also know that the instant center C has a zero velocity. Since we don't know enough to find the velocity of O, we can start by finding the angular velocity omega of the spool. We know that the magnitude of angular velocity is equal to the velocity of a known point on the spool divided by the position vector of that point with respect to the instant center. In our case, that's given by the velocity of A divided by the position vector of A with respect to C. Plugging in our variables to that equation, we have that VA divided by big R minus little r. Since velocity of A is moving to the right, the spool is rotating in a clockwise direction, which makes the angular velocity negative in the k direction. After finding angular velocity, we can use that value to solve for the velocity of point O. We know that the velocity of point O is equal to the velocity of point C plus the angular velocity cross product the position vector of O with respect to C. Plugging in our known variables, we know that the velocity of C is equal to 0. We also know that the angular velocity is equal to VA over big R minus little r. And we can see that the position vector of O with respect to C is equal to positive big R. Simplified and in vector form, we have that the velocity of O is equal to VA times big R divided by big R minus little r in the positive I direction. After plugging in our known values into the variables for our two equations, we have that the angular velocity is equal to negative 0.8 meters per second divided by 0.9 meters minus 0.3 meters in the k direction, which gives us the magnitude of the angular velocity is equal to negative 1.3 rads per second, and the angular velocity is equal to negative 1.3 rads per second in the k direction. Plugging in our known values for the velocity of O, we have that it's equal to 0.8 meters per second times 0.9 meters divided by 0.9 meters minus 0.3 meters in the positive I direction, which gives us the magnitude of the velocity of O as equal to 1.2 meters per second, and the velocity of O is equal to 1.2 meters per second in the positive I direction. Thank you.